Hi guys, and welcome to AskRose Homework Help live stream. Tonight we're going to be covering the quadratic equation. I'm sorry we're starting a little bit late. We had some technical difficulties on our end. So yeah, we're going to hop straight into it here just in a second, and we'll get right into our quadratic formula. We will still be going the full time. Don't worry, we'll still do the 30 minutes. So we'll go to it'll be 7:35ish our time.
7:05.
Sorry, 7:05 our time. Which will be about 30 minutes from now. I'm so sorry we started late. Sometimes those things happen. Technology, am I right? Anyway, so yeah, today we are doing the quadratic formula. Very exciting. We're going to hop into kind of our first slide here. So what is the quadratic formula? The quadratic formula is a way of finding x-intercepts of a function or an equation. Or some teachers may call it like finding the roots of an equation. Essentially, it's a way of finding, if you graph a line or a function, of where it equals 0. But it's called the quadratic formula because it only applies to quadratic functions. And a quadratic function is a function that is squared, because squares and quad and quadratic, they're all based on the same root words. So we've got any formula that kind of has an x squared in it, where an x squared is the highest level term. You can do the quadratic formula on it to figure out where it crosses the x-axis. And those are its x-intercepts where y is equal to 0, essentially. So I'm going to give you guys the form of the quadratic formula. It looks really complicated and lengthy, so it can be a little bit scary if you haven't seen it before. But it's negative b plus or minus the square root of b squared minus 4ac, and all of that goes over 2a. Now I know what you're thinking. That probably looks a little bit ridiculous, because it is if you haven't seen it before. A lot of people like to come up with fun little rhymes or like sayings to remember it, so a lot of people do like the negative b plus or minus square root plus or minus square root b squared minus 4ac b squared minus 4ac over 2a over 2a. And if you come up with like a little rhyme like that, it becomes pretty easy to remember. That's completely up to you. Some people like other songs or just another mnemonic way of remembering it just to make things easier. But yeah, negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you haven't seen a plus or minus before, that just means that we're going to have kind of two separate answers, one where we add negative b to something and one where we subtract something from negative b. And that's all that means. So where are we getting these letters from? That's probably a great question that I'm sure you're all wondering. So I'm going to hop here into our first example probably to start that, explaining where those come from. So it's kind of like what I said. Some teachers might ask the question like find the roots and give you a quadratic equation. So the way it works is your roots come from this if you use the quadratic equation you plug in. But we need to decide, because we've got our quadratic formula, I'll rewrite it here so we can see it for reference. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're probably wondering, what is a, b, and c? Where are we getting these letters from? So a, b, and c are the coefficients of x squared, x, and the third term there, which does not have an x attached to it. I'm going to highlight them in red here, so kind of like whatever this term is in front of the x squared, whatever this term is in front of the x, and whatever this last term is. And that's going to be a, b, and c. Sorry, had to switch my pen color back over. So for this problem in particular, we've got an x squared minus 5x minus 14. So we're going to have our a term is equal to the coefficient on that x squared. Wherever that x squared is in the equation, your a term is its coefficient. The coefficient is just the number or multiple that's in front of it. Now, we don't have a number written in front of the x squared, but what that really means is we just have an assumed 1. So a is equal to 1. Then we have our b term, And our b term is going to be whatever is attached to the x. So in this case, that's a negative 5. And finally, our c term is going to be whatever is the last kind of term without an x. It's all by itself. And that's going to be negative 14. So the first thing we're going to do here is, now that we have these, we can plug into our equation. So we're going to go negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm going to write x equals, I'm going to go with negative b, so negative negative 5 is just positive 5, plus or minus the square root of b squared. Now, negative 5 squared, it's negative 5 times negative 5, it's a negative 5, so it ends up working itself out to be positive because it's negative times a negative. So we've got positive 25 minus 4 times a, which is 1, times c, which is negative 14. And I'm thinking in my head here, I'm not sure I'm immediately recalling what 4 times 14 is. I think it's 56. Let me double check that real quick. Yeah, it's going to be 56. Okay, so we're going to do square root of 25, and then these minuses, the minus 4 and the minus 14, that cancels out and becomes a plus. So we have a plus 46 here, sorry, 56 here on the inside. And then we're going to take that whole thing over 2 times a, which is just 1, so it's really just 2. And we'll carry down our x equals. So I'm going to draw a little arrow here. We're going to kind of 5 plus or minus the square root of, and then we've got the 2 on the bottom. 25 plus 56, we're going to add those real quick. And we're going to get 81 for our 25 and 56. Now, the really nice thing about this one, it's actually really, really nice, is if we try and simplify this, like this is our answer if we leave it in exact form. But we kind of want to find the exact answer so we can get both of those roots for the plus and the minus. So the next step we're going to do is simplify the square root. And the square root of 81, what number squared is 81? It's 9. So we're going to take the square root of 81, which is 9. Sorry, the writing is weirdly overlapping there a little bit. So we're going to do 5 plus or minus 9 over 2a. Wow, the slide does not want to write down there. Okay, I'm going to do 5. Let me grab an eraser real quick and erase some of this extra math here. That way I have more writing space. Alright, so we're going to do 5 plus or minus 9, because that's the square root of 81, over 2a. So the first thing we're going to do is do our plus. So 5 plus 9 is 14, and 2a is just 2. So 14 over 2 is equal to 7. And then we're going to do our minus, so 5 minus 9. 5 minus 9 is negative 4. And negative 4 divided by 2 is just negative 2. So our two answers are going to be x equals negative 2 and 7. And that is going to be our answer here. I'll circle it in red. And what this means is that for this function, x squared minus 5x minus 14, if you take that function, you put it on a graph, the places where it's going to cross the x-axis, so your y-coordinate is going to be 0 at that point, is going to be at the points x equals negative 2 and x equals 7. Alright, so we're going to move on into our next slide here. And I'm going to work through you guys with this one again, just because, you know, it's kind of a new formula, maybe a little bit scary if you haven't seen it before, but it doesn't need to be scary once we understand it. And we just basically can plug in our numbers once we know what they are. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So first thing we're going to do is find our a, b, and c, which is going to be 1, because the coefficient of the x squared is 1. It's going to be 15, because the coefficient of the x is a 15. And it's going to be 50, because 50 is our last term that we kind of have by itself. If you also notice, all of these are set equal to 0. It's very important we set these equal to 0, because we're finding when the y-coordinate is equal to 0. And this is, it's kind of like acting like a function. If this was y equals x squared plus 15 plus 50, we want to find out where y is equal to 0. So it always has to be set equal to 0. That's very important. So here we go. Let's go into the problem. So now that we've got our stuff, we can start to plug in. So we've got a negative 15 plus or minus the square root of 15 squared. And 15 squared is going to be 15 minus 15. That doesn't feel right. 15 squared, I believe, is, sorry, I'm blanking and I did not bring my calculator with me. I could multiply it out by hand. But it should be 225. So we're going to do negative 15 plus or minus the square root of b squared, which is 225, minus 4 times a, which is 1 in this case, and then c, which is 50. So we're going to do negative 15 plus or minus the square root of 225 minus, and then 4 times 50 is 200. And we only have the 1 minus, so we don't need to worry about doing any sort of like multiplying negatives by each other. And then that's going to simplify down again. Again, that's all over 2a. And then 2 times a is just 2 times 1, so it's just 2. So we can simplify in the radical then, and that's going to be 15 plus or minus the square root of 225 minus 200 is just 25. And then we're going to take that, and we're going to divide it by 2. So now that we're at this point, we can start to really simplify and work our way down. I'm going to do the plus first, so I'm going to do negative 15 plus the square root of 25. You guys remember the square of 5 squared is 25, so the square root of 25 just inverses that, and it's going to be 5. And that's going to be divided by 2. So negative 15 plus 5 is going to be negative 10 divided by 2 is negative 5. So we've got x equals negative 5. And then we're going to do our other one, which is the negative 15 minus 5, which is just going to be negative 20. Negative 20 divided by 2 is going to be negative 10. So we've got x equals negative 10. So our answers on this one are going to be x equals negative 5 and negative 10. And those are going to be the two roots of the equation. If we end up graphing this function and we go look at a graph, we'll see that the points x negative 5 and x negative 10, it will pass the x-axis, which means it has a y-intercept of 0. Alrighty, now we're going to head on to our next thing here. We're going to move on to our next slide. Here we go. Make sure my ink color is correct. Right, here we go. Find the roots of x squared equals 11x minus 28. So this is going to be pretty super fun because we have to arrange it first before we can solve it. And that's just going to be some very simple algebra rearranging. You don't need to worry about it being too complicated. I'm going to walk you through it every step of the way. So the first thing we got to do is we got to get it into the quadratic form, so that way we can apply the quadratic formula to it. So I'm going to take our x squared, and well, we've got an 11x on the right side, and we want a 0 on the right side. So I'm going to move the 11x over, and that means we have to subtract the 11x from both sides. Got to do it here too. So we have x squared minus 11x, And then, well, I also have a negative 28 on the right side, and I don't want that there. I want a 0, so I gotta add 28. And that means I have to go add 28 on the left side as well. So if we do that, and the right side cancels to 0, then we have x squared minus 11x plus 28 is equal to 0. So we're going to identify our A, our B, and our C. So C is going to be 28 if we work our way backwards. That's the term with nothing on it. Our B is going to be negative 11 because it's the coefficient of that whole x term, and that includes negatives. And then A is just going to be 1 again, which is really nice to factor. Pretty simple. Alright, so we've got, we're going to plug into our good old quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. You guys are going to be so tired of me saying that by the end of tonight. So we're going to go ahead and plug into that. So our b is negative 11, so it's going to be positive 11 plus or minus the square root of b squared. 11 squared is 121. And then we're going to do minus 4 times a. A is 1, so I'm not even going to bother writing it down because it's 4 times 1, which is just 4. And then times c, which is 28. And that is going to be all over 2, because 2 times 1 is just 2, so 2a is 2. Great. So now I'm going to take the 28 times 4. So we can subtract it from the 1, so we do 28 times 4, this is going to be, let's see, times 2 is going to be 56, so times 2 again is going to be 112, yeah, so you've got 112, so 121 minus 112, so we're going to do 11 plus or minus the square root of 121 minus 112, divided by 2. And now we can do the, thank you to my tech guy for helping move my picture around, very helpful, so that way I'm not covering up any of the math, sorry about that. So we've got 11 plus or minus, I'm going to simplify inside the radical now. So 121 minus 112, it's actually 9, and then that's divided by 2. So we need to find the square root of 9. Luckily, 9 is also a really nice square number, and that comes from 3 squared. 3 squared is 9, so the square root of 9 is 3. So we have 11 plus or minus 3 over 2. So I'm going to do the plus side first. I'm going to find 11 plus 3 divided by 2. That's 11 plus 3 is 14. 14 divided by 2 is 7. And then we're going to do 11 minus 3 divided by 2. And 11 minus 3 is 8, divided by 2 is 4. So x equals 4, and x equals 7. When we go look at a graph of this function, our x-intercepts, so where y is equal to 0, would be located at x equals 4 and x equals 7. Something I might clarify if you guys are not familiar with it, because some of you might be looking at this being like, oh my gosh, but PEMDAS, aren't you supposed to do division first? Why are you adding them? And that's because when you have a fraction, because fraction is kind of a form of division, if anything is on top of that fraction or on the bottom of that fraction, it's treated like it's in parentheses. They're actually there, we just don't write them because it's kind of a lot of writing, but they are actually there. So this is really like saying 11 plus 3, and we're going to add that first before we divide. So it doesn't follow the order of operations because you can't see the parentheses, but they really are there. I promise they exist, either on the top of your numerator or in the bottom, your denominator of your fraction, whatever you're dividing by. You can always simplify each of those terms inside the top and the bottom first, and that will always be a valid way of doing things. So for this problem, our answers are x equals 4 and x equals 7. Alrighty, now we're going to go ahead and move on into our next problem here. Alright, this one we're going to find the roots of x to the 4th minus 2x cubed minus 3x squared equals 0. Now this probably looks even scarier than some of the other problems we did. I know we've already thrown a really scary equation at you, right? Quadratic formula, pretty scary. Not that scary. We're working through it, right? Everything is making sense, hopefully so far. If you have any questions, please ask them in the chat. I will do my best to explain. Also, if you have questions that you'd like us to address on stream that are kind of about this topic, you can go ahead and submit them to our worksheet. It's in the description, and I will take a look at those if we have time. Additionally, we open Ask Rose in about 3 minutes. If you want to call, we're open from 7 to 10, and we're open Sunday through Thursday, so we're always willing to help tutor, especially with stuff like this, and it's totally free. All you have to do is call, chat, or email. Okay, so now we're going to approach this problem. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Are any of you tired of hearing me say that yet? I could sing it next time if it makes you feel better. I'm not going to do that. The first thing we're going to do here is, this is not in quadratic form, so we got to get it in quadratic form, right? How do we do that? Well, we need to look for a common factor. Usually if you're given a question like this and it's meant to be like a quadratic formula, there's going to be a common factor between all of the terms that we can use to make this a simpler problem. So what we can do is we can look at all the terms, and let's look at the smallest term. Is there anything in the smallest term that's also in all of the bigger terms? And there is. It's an x squared. So if I take this x squared and I pull it to the outside, right? And I put everything else in parentheses, and I do another x squared, because x squared times x squared is x to the fourth. And then x squared times negative 2x is negative 2x cubed, right? Because we're just multiplying through. And then this one is just going to be a minus 3, because he doesn't have a term anymore, because we took out the x squared. And that's going to be equal to 0. Now we can kind of treat these like separate parts of the equation. Because it's multiplication and we're looking for what equals 0, if either one of these is 0, your answer is going to be 0, which is correct. So, the first thing I'm going to do is just look at the first term, x squared equals 0. So if it's x squared equals 0, and we want to find the value of x, we just take the square root of both sides, and wow, the square root of x is 0, so x equals 0, and that's one of our roots. Then we're going to look at this part. Now this part is a quadratic formula. That means we can use the quadratic formula on it. So we can take our x squared minus 2x minus 3. We've got an a equals 1, b equals negative 2, and c equals negative 3. And if we take all of those, then we're going to do our quadratic formula. So we're going to do 2, because it's a negative times a negative 2, plus or minus the square root of b squared, negative 2 squared, negative times a negative, the negatives cancel, so we've got 4 minus, and then 4 times 1, so 4 times, and then negative 3. Oops, sorry, messed up with my pen a little bit there. So that negative 4 times a negative 3 is going to be positive 12. So this is really saying 2 plus or minus the square root, the square root of 4 plus 12. And that's going to be divided by 2a, and 2a in this case is 2 times 1 because our a term is 1, so it's just 2. And this square root actually simplifies down more to a, let me come over here, to plus or minus the square root of 4 plus 12 is 16 over 2. Now the square root of 16 is another square, again very convenient, super useful. So we have that 16, and that's going to be 4 squared. 4 squared is equal to 16, so the square root of 16 is 4. So we have 2 plus or minus 4 over 2. So the first thing I'm going to do is do a 2 plus 4. 2 plus 4 over 2 is going to be 2 plus 4 is 6, divided by 2 is 3. And then we're going to do 2 minus 4 over 2. 2 minus 4 is negative 2 over 2, which is equal to negative 1, because we just, the 2's cancel and we just have the negative 1 left if we pull out a negative 1 out of our 2 term. So we actually end up having 3 solutions to this equation, which makes sense because it is actually not entirely a quadratic, but is in fact a quartic function. But we can use the quadratic formula to solve it because of that. because we were able to pull the x squared out of all the other terms. So our answer for this one is x equals -1, 0, and 3. And actually, we can go take a look at a graph for this one. I'm going to exit out of my presentation here real quick. Let's see how well that works. I would like to keep my incantations. And I'm going to go ahead and pull up a slides. I'm going to pull up a Desmos window here. So this is Desmos, which is a graphing tool we showed you guys earlier in the year. If we go look at my PowerPoint, then we're looking for x to the 4th minus 2x minus 3. So -2 minus 3. I'm going to go back to Desmos. So I'm going to say y equals x to the 4th minus 2x to the 3rd minus 3x squared. So this is our quadratic function, which looks a little bit weird, probably something you guys haven't quite seen before. If we graph our quadratic formula right next to it, our quadratic function that we took the formula of was an x squared minus 2x minus 3. And if you look at that, that one looks far more like a normal quadratic formula that we've been using. So if we apply both of these, then if we only look at the one we did, because we solved for roots, right? And we found the roots of the big equation, and that was 0, -1, and 3. So if we zoom in on this graph here, we can see that we've got a -1 at 0, 0 at 0, and finally 3 at 0. So that's how you can kind of factor out other equations and break it down into this sort of function. So yeah, there are multiple solutions, which is more than you would normally get with a quadratic formula. You'd normally get 2. In fact, because it's a quartic function, there are actually 4 solutions. It just so happens that because our x squared term factored out, because we want to be able to use the quadratic formula, that the x squared equals 0 just becomes x equals 0, but you have the plus or minus in there. So if that was another number, you'd actually have 2 roots, not just the 1. So really, your number of roots per equation that you have is proportional to, or it's actually the same as whatever the highest power number on your exponent for your variable is. So like an x to the 4th equation, so in this case, the one we just worked, the x to the 4th minus 2x cubed minus 3x squared, that's going to have 4 solutions, but 2 of them are the same at 0, so it really just looks like 3, and we only solved for 3, really. And then also as well, your if you have a cubic function, so like x to the cubed minus 2x squared minus 3x, that is actually just going to be 3 roots instead of more than 3 or less than 3, because a cubic function is going to have 3 roots because it's x cubed or x to the 3rd. So yeah. Anyway, I'm going to go back to our slides now, and this is kind of where we were. So we're running close on time here. Whoops, gonna hop through our presentation. So we're running close on time here, but I'll leave you guys an equation to work with on your own at home, and then if you have any questions, you can submit them to the worksheet page, and one of our other tutors would be happy to work through this with you. Maybe it could even be me, who knows? And we'll work through this one with you, but I'll leave you with it, and I'll try and get you started. The first thing you're going to want to do is sort out the sides. So we're going to make this into quadratic form, so a 9x squared minus 16 is equal to 0, which is interesting, right? Because we don't have an x term, but it turns out not having an x term is actually totally okay. Just like last time in the last video where we did FOIL and factoring, and you might not have had a middle term, that's still okay. So we're going to do a equals 9, and there is no b term in this case because there's nothing attached to an x, but our c term is going to be negative 16. And that should probably be enough to get you guys started. B is 0 if you need that as well. And again, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There is an extra method of checking your answers that you can do if you want. If you factor them normally, they also will work out to be the same roots. But once you get into more complicated equations where you have decimal points, that's a lot harder to do by factoring. But for simple equations like this, you can just factor them normally, and factoring them will also get you the roots if you set those roots equal to 0 and solve for them that way. Yeah, so that's what I'm going to leave you guys with tonight. I hope you guys work through this problem, and I hope you've enjoyed the stream. Maybe you learned something. If you have any more questions, please submit them to our worksheet page. Give us a call. Let us know. We also have chat and email. It's going to be fantastic. Thank you guys so much for joining us for another great night at AskRose Homework Help Live.